linear relation and rate of change. So in these set of videos, we are trying to analyze the real situation and write a mathematical model, interpreting different terms like rate of change. And we are assuming that the rate of change is linear in our examples. It may not be so in most of the cases, right? But that's an assumption. So when you look at these graphs, first have a look at the graph and see what it relates to. So the question here is, interpret the given situation, and situation is, water is being warmed on a gas stove. So when you warm something, then its temperature will increase. We written here heating water. Now in these set of videos, we have not given you all the details. So a lot of things are missing even from the graph. It is done on purpose. So this is a default graph where we are showing x along the horizontal axis and y along the vertical axis. You may define your variable as x and y, but you can change them, right? Second, we have also shown any units along x and y axis. We have left it to you. Depending on your story, you can write down the units, make your story. Correct? So that is the whole exercise. So it is one step more than what you had been doing in the previous videos, where we gave you the scale and the parameters, rather the variables along the axis also. Correct? So define your variables. So now let's go through the questions. So once you study the graph, define variables and then calculate what is the rate of change and what does rate of change mean with reference to your story. What is the initial value and what does initial value mean? What would the temperature be after 10 minutes? What is the equation of the line? So when you write equation of the line, you can of course write in terms of x and y, but you can write in terms of your defined variables. So answer these questions. You can stop the video. Once you have answered all the questions, then listen to my suggestions. Here are my suggestions. So we should start by looking at the graph and seeing what the graph is telling us about. So it says water is being warmed on the gas stove. So that means the temperature of the water increases as we warm it, right? So the two variables for us are time and temperature, correct? Right. So the time could be in seconds, minutes, hours, like that. But here in question we have what would the temperature be after 10 minutes. So that means this should be less than 10 minutes, right? So it is a good idea to write units in minutes. So that is the reason why I am selecting time in minutes, not in seconds or hours, because question here relates to the units, right? So, and the temperature is also mentioned here. What would the temperature be? So here we know that dependent variable is temperature, and the unit of temperature seems to be degrees Celsius. So that's a good option, right? So we will write degrees Celsius as the temperature units, right? So we define our variables here and we say, well, the variables are independent variable time in minutes, T for time in minutes. It's important to write units, and capital T for temperature in degrees Celsius. So we define our variables. Second question is, what is rate of change? To find rate of change, we need to take 2 points on the line. As you know, any 2 points will work for us since it is a straight line. As a part of an exercise, you can always check it by 2 different points, 2 different set of points. Let's take these 2 points. Bigger the triangle, accurate, more accurate the result is. So these points for us are 0 and 20. So let me write 0 and 20, and this is 8 and 40. So these are our points. Rise is how much? Rise is 40 minus 20. So we have rise of 20 here. And the run is from 0 to 8, and we have run of 8. Rise over run gives us rate of change, and rate of change therefore is 20 divided by 8. Correct? Since the line is going upwards, we see the rate of change is positive. It's kind of a check, right? Always see. If the line is up, the rate of change has to be positive, right? So 8 goes 2 times 16, and then we have 4 left, 45 times. So we get 2.5. Rate of change units are change in Y, which is degree centigrade, over change in time, which is in minutes. So that is what is rate of change in the given example. Now what does rate of change mean? So rate of change here means that in every minute temperature increases by 2.5 degrees Celsius. You can write like the rate of change reflects increase in temperature per minute, right? That is another way of saying it. You can say 2.5 degrees centigrade per minute is the increase in temperature per minute. Right? So rate of change here is change in temperature over change in time. The speed with which temperature is changing is 2.5 degrees Celsius per minute. So it shows change in temperature with time. What is the initial value? The initial value is always at t equals to 0, and it is 20 degrees Celsius. So started with 20 degrees Celsius. What does initial value mean? Initial value means that when the heating process or warming up on the gas started, at that time the temperature of the water was 20 degrees Celsius. What would the temperature be after 10 minutes? Now, we started with 20 and we are increasing, correct? So we say 20 plus how much? 20 plus. After 10 minutes, since it is going by 2.5 per minute, it should be 2.5 times 10, right? So it should be 20 plus 25 or 45 degrees Celsius. So that is the temperature which is expected after 10 minutes. At times, you can extend the graph. We call it extrapolation. You can extend the graph and then read from the graph itself. Do you see? So if you extend it, it will go to 45. So probably somewhere here. So that is called extrapolation, right? So you can do that on the graph. In most of the examples, I have deliberately cut the graph in a way so that you can't read by extending, because I'm encouraging you to do the calculation, get a model, and then get the answer. Correct? That's the reason. But sometimes you can extend the graph and get the answer. What is the equation of the line? Generally, we write equation of the line as y equals to mx plus b, where m is rate of change and b is the initial value, correct? Now here, our dependent variable is temperature T. So we should write capital T for temperature equals to rate of change 2.5, independent variable time plus initial value 20. Now since we have defined this variable here, we know temperature is in degrees Celsius and time is in minutes. If you have difficulty in this question after 10 minutes, you can plug in 10 here and get your answer. It's a good check. If I write 10, 2.5 times 10 is 25, 25 plus 20 is 45. Units for temperature are degrees Celsius. So that is how you can complete this question perfectly. Thank you and all the best.